All right, so we know some of you are still working on that quiz from Friday. However, here is our warm-up that is just like Friday's quiz. So go ahead, take a minute, look at that example where you have x plus 8 equals 13. And thank you.
She right there, Abby had it done too, that's what she wanted, the 2-4 version of it. Study guide intervention.
Okay,
2-4,
is that what she took out and was showing you? Okay, so how many have A, put up a 1. If you have B, hold up a 2. If you have C, hold up a 3. And if you have D, hold up a 4. All right, Madison, Landon, good. Nevaeh, Zoe, got you. Dominique, got you. All right, Nick, see that? I see you, Abby. What you got, Logan? All right. All right, Colton. Okay. Luke, did I see yours? All right. And Sierra. Okay. Awesome. So it looks like a majority of us are split between B and C. I think C did take the majority. So let's talk about what we should do. So, Zoe, what did you do to start this problem?
I did x plus 8 minus 13 and then x plus 8 minus 8.
Good. So she had her 13 and her negative 13. Okay, Dominique, what do you do next?
I subtracted 8 on both sides.
Good.
Then I got 5 and negative 21.
Perfect. Okay, so if we had B, do we see how we flip-flopped our signs? So correct answer was in fact C. Right? So we are moving away from absolute values. We're moving away from solving those types of equations. And we're actually going to start looking at ratios and proportions. So the first half of chapter 2 was all about solving equations. We looked at linear, we looked at multi-step, and we ended with absolute value. Now we're in the second half of that unit, and now it's on ratios and proportions. So if you think about the word ratio or you think about the word proportion, anybody have something that comes to mind without really kind of looking down maybe at what I put on your handout? Anybody think of anything when they think of ratio or proportion? What do you think of, Logan?
Separation.
Okay, think of separating. What do you think of, Abby? Fractions. And fractions are our best friends. What do you think of, Dominique?
I was thinking of decimals.
All right, you think of decimals. We can have decimals in there too, because decimals and fractions are they're the best friends. So our objective for today is going to be able to write and use ratios, rates, and then tomorrow and the remainder of this week, we're going to write and solve proportions. So proportions are the more complicated part of a ratio. So today we're going to make sure we just understand a ratio. So here's an example of how we might use a ratio. And I know you guys in math, you see numbers and words together and your brains say, no thank you. But this is kind of a cool example of how restaurants in different countries relate to restaurants in the U.S. And if you look at that table, what countries have the most restaurants? What do you think, Dominique?
I think Italy.
Okay. So Italy might. I don't have Italy on my table. I just looked at some of the bigger ones. Abby, what do you think? Yeah, the U.S. That's why they are talking about how the pandemic has really hurt a lot of restaurants because we, as a culture, rely on going out to eat. So the table above shows the number of restaurants of a certain popular fast food chain per 10,000 people. How could we use that information to get to 1 million people or 500,000 people? So if the table gives you 10,000 and we wanted to get to 1 million, how could you go from 10,000 to 1 million? What do you think, Dominique? Yeah, we're going to multiply. In this case, you're going to multiply by 100. If you wanted to get from 10,000 to 500,000, you'd multiply by 50. So how does that relate to what we're going to talk about today? Well, we're going to talk about how we could compare 10,000 people to 1 million people, to 500,000 people, etc. Okay? So vocab. All right, Miss Nevaeh, will you read my definition of a ratio? All right, so a ratio is a comparison. A ratio is a comparison. Make sure you guys fill in the bold words. So you're filling in those bold words. Okay? In mathematics, we use it to compare two numbers by division. In math, we use it to compare two numbers by division. Examples of ratios. Examples are x divides y. There's our... Someone said a ratio was a fraction. There's our fraction. Not quite our decimal, but our comparison. So you can compare x to y. So we write ratios in one of three ways: a fraction, a comparison, or as x to y. Everybody able to fill in that first page of notes and our bullet points? Logan, did you get them all, bud?
Filling in the bullets right now.
Okay. All right. When writing a ratio, you have 3 triangles and 2 squares in our example. So we can write that ratio as a comparison of a fraction of 3 over 2. You can write it as the comparison between 2 points. So 3 triangles, the 3 always comes first, and the 2 always comes second. So it's 3 over 2, or you write 3 to 2. We might also talk about it as an example with treats in a box. So if I give you a bag of candy and I say, all right, there are 3 red candies and 5 yellow candies, what's the comparison of red to yellow? 3 to 5. How many candies do you have in all? 8. So when you do a ratio, it doesn't show you the total number. It shows you a comparison of 2 parts. So I think that's one of the most confusing parts of the ratios. It doesn't show you the total number. It shows you a comparison of the parts. One of the things we're going to focus on today is equivalent ratios. We're going to focus on equivalent ratios. What part of the word equivalent reminds you of another math word? Equivalent reminds you, what other word does it remind you of, Zoe? Equals. Good. So equivalent ratios are 2 ratios that are equal to each other. Equivalent ratios are 2 ratios that are equal to each other. So we're going to notice that they can be multiplied or divided to be the same fraction. We can multiply or divide them to be the same fraction. There are 3 steps to finding equivalent ratios. There are 3 steps. The first step is what, Madison? What's step 1? Okay, good. Step 1 is rewrite. Sierra, what's step 2? Perfect. We're going to multiply or divide the denominator and numerator by the same number. Okay, and Nick, what's step 3? We're going to compare them. Okay, determine whether the ratios 2/3 and 16/24 are equivalent. All right, Madison, your hand was up real quick.
So they are equivalent because if you divide 16 and 24 by 8, you will get 2/3.
Excellent. So Madison said they are equivalent because she took 16 over 24 and divided that by 8 over 8. And when she divided that by 8 over 8, 16 divided by 8 was 2. 24 divided by 8 was 3. So 16/24 simplified to 2/3, which is my other ratio, which made them equivalent. Example 2, 7/8 and 49/56. All right, Nevaeh, what do you think? All right, so she says yes. Dominique, I saw your hand up. Do you agree or disagree?
I agree.
You agree. All right. So, Luke, you've been awful quiet up there. How could I make 49/56 and compare it to 7/8? Divide them both by 7. Awesome. So 49 divided by 7 is... And 56 divided by 7 is... So, are they the same? Yes. How many of you remember doing this last year?
There you go.
A little bit? Okay? Determine whether the ratios 6/10 and 2/5 are equivalent. All right, Dominique, what do you think? So we got a yes. All right, Abby, what do you think? All right, so Abby says no. What do you think, Nevaeh? All right, so let's take a vote. We got a yes, we have a no. Luke, yes or no? Okay, Madison, yes or no?
No.
Landon?
No.
Zoe? Nick? Sierra? Logan?
Yes.
Colton? You go with no, right? Abby, I already asked you, right? Okay. So I got 9-2. How could we determine if it is yes or no? What could I do? And you have two choices. Do we want to change the 6/10 or the 2/5? All right, Logan, what do you think?
Actually, you can simplify both with each other, or you get at 3e/2.
Okay, so let's simplify the 6/10. Let's go with that one, because I think that's what you're hitting at. So what'd you do with the 6 to get 3? What'd you divide it by?
2.
Okay, so Logan said let's divide 6/10 by 2/2. So 6 divided by 2 is 3. 10 divided by 2 is 5. Is 3/5 2/5? No. So my 9 no's had it. Those are not equivalent. 3 and 2 are not the same. Okay, this time I want to try something different. We've done a lot of dividing. Let's multiply, because that was the alternative way, right? So one way is to divide, the other way is to multiply. Madison, do you know what I'm going to multiply by? Or do you want to tell me yes or no?
I could do both.
All right.
So I said yes, and you can multiply them both by 5.
Okay.
We can multiply 1/6 by 5.
Yeah, I would just have to multiply 1 by 5, right?
Yeah.
So you could take 1/6, and instead of trying to divide, you could multiply to create, what's it called when I multiply two fractions to have the same, what are we looking for? We want them to have the same what, Dominique? Yeah, denominator. It's okay, Nevaeh. So like, instead of dividing, you can multiply to get that same thing. So 1 times 5 is 5. 6 times 5 is 30. And that does, in fact,
Yes. Good.
that's what I said. I wanted to work both ways. You don't always have to divide. Okay. We know in here we do a lot of multiple choice. This one is not multiple choice. This one is multiple select. So it says circle all the equivalent ratios. So I want to know, is it equivalent? So yes or no. So you kind of have to look at A, you have to look at B, you got to look at each one individually to see if it simplifies to 1/2. So Abby, what could I do to 5 compared to 10 to see if it compares to what half? What could I do to compare them? Perfect. I'm going to divide top and bottom by 2/2. So 5 divided by, not 2, sorry Abby, I agreed to you. Not 2. Yeah, by 5. Because we want that bottom to be 2.
Remember, guys, you can write these as fractions. And so if it's easier for you to see what's going on in this form, you could write it as fraction.
Is A yes or a no? So we circle A. Okay, Nevaeh, what should I divide my example in B by? Or what does 6 and 16 both divide by?
2.
Okay, so let's start with that. If you don't know, pick a number you know they do divide by. Okay, Madison, what'd you get?
I got no for that one.
Okay, so she got no, because what did 6 over 16 reduce to? If you divide it by Nevaeh's 2, we get 3 over 8.
Oh, no, that's
And that's not 1 to 2, right? That's not a half. What do you think?
I just want to say how I've been doing this since this is 1 over 2. I've been dividing the second number by the first number.
Okay. So did everybody understand what Madison said?
No.
All right. So Madison said her top number here is 1. So she's been taking the first number in her fraction and dividing by that number. So if you took 12 and you divide it by 12, that would give you 1. But if you take 32 divided by 12, that's a little messier, right? Is 32 going to divide by 12 to be the number 2? No, it becomes like 2.6 repeating. So instead of trying to find the singular number it divided by, Madison said, hey, I'm going to divide the top number to see if it matches. So she got the 1 to match, but then the bottom didn't match. So what'd you get for letter C?
No.
A no. Go ahead. Letter D is yes. I think that's correct as well. And what did you divide by to compare them? Or 50, exactly. So Madison's suggestion of dividing by this top number to get 1, in this case, gives an example that works. 50 divided by 50 is 1. 100 divided by 50 is 2. So we get yes. Okay, letter E. We have 64 and 120. So do we want to divide by 64 because we like Madison's way?
Yeah.
All right, so 64 divided by 64 is 120 divided by 64 is not 2, right? I don't know what 120 divided by 64 is. It's 1.875. So is 64 to 120 the same as 1 to 2?
No.
No. What's a ratio we could make in our classroom? I can think of a few. All right, you could do boys to girls. Thinking in terms of people again, what else could we compare? Go ahead, Madison. All right, people who have glasses and people who don't. We have quite a bit of us that wear glasses, actually.
They go to
So you could compare clothing.
Are we including
Okay, well, couldn't that be a ratio? Could you do adults to kids? So like Logan said, are we including the teachers? I guess we really up your odds, don't we?
It's 11 to
Glasses
3.
party,
Yeah. So you can make ratios and comparisons all the time. You just easily all created 5 problems within this room doing ratios. You did boys to girls, glasses to no glasses. Someone said hoodies to no hoodies, adults to kids. So you can do tons and tons of different ratio comparisons with real life examples. Sometimes we use them in word problems. And I know you guys see words and you're like, ugh. Do you want to read it first?
I can.
I mean, I know you want to tell me my answer, but I need everybody else to have a chance to read it. You want to read it?
Yeah.
All right, you can give me my answer. I'll let Nevaeh read it.
Okay. You're on Abby, what is that? Which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race. While the long running, he rises by more than he runs. Therefore, the long runs 4 miles for every 14 miles he runs back. Now, let's apply the ratio in front and wiggle with values.
All right, Miss Madison, what's my ratio?
4 over 14.
Okay, so she compared 4 miles running to 14 miles biking. Now, it says to find an equivalent value. Each of you are going to give me an equivalent value. So you got to listen to what your classmates say so you don't repeat it. So Madison, you can go first.
I got 2 7.
All right, so she said 2 7ths. Landon, you can use a calculator.
This is
Yeah, you're going to get some pretty big numbers.
Shing Shong.
Well, it needs to be a different one, so you don't want to do something other than that. Remember you said you could multiply? Let's multiply each number by 2. Yeah, 4, yeah.
I was gonna divide by 4.
Yeah, there you go.
16 and 196.
Oh my.
All right, so Landon went real big. He multiplied by what? All right, we'll make it easier. Zoe, if Landon went to 16 over 196, what did he multiply by? How do you go from 4 to 16? 4. 8 would be if you were comparing the 2 7ths.
Oh.
I know what you did. You said the 2 7ths to 16. All right, who else has an equivalent fraction they want to share? Nick, you put your hand up. What do you got?
32 to 112.
32 what?
32 to 112.
All right, so to get to 32, you multiply by 8. So 14 times 8. His 196 is off.
I was just thinking the same thing.
Very good, Nick. I thought you watched them.
56.
Yeah.
I was confused.
That's a good point, that if he was, when you're doing a math problem, if the answer looks really off, really wild, check your work, because it usually is.
So when Nick told me 112, I went and said, hey, 196 can't be right. So when we talked about that in here the other day, didn't we? We talked about how we did that absolute value problem, and we did all the work, and the absolute value was equal to what type of number? Anybody remember the absolute value problem we did? And we did all the work, and then it was no solution because the absolute value was equal to a negative. And we talked about how sometimes in math you do more than you need to, or you kind of make that mistake, but you catch yourself. And that's why we reiterate the importance of our check steps. Anybody else have another one? I saw Nick gave me his. Abby, Luke, Sierra, anybody want to share another equivalent fraction? All right, everybody kind of went to 2/7, right?
That's a good choice.
That's the one I picked.
How many of you would want to run 4 miles and bike ride for 14?
Never
I
that.
ran 4 miles in one point.
You in one single run?
I do it.
Like you ran 4 miles in a marathon?
I would rather jump off of a building. It takes me 14 minutes to ride by myself.
All right.
And I run.
So last thing, what must be true about the numerator and denominator of ratios for them to be equal? What has to be true? If you want two fractions to be equivalent, what has to be true? They have to what? Go ahead, Dominique. Yeah, they have to simplify to the same thing. Yes, it is. Okay, so if you flip that note guide over one more time, let's go through real quick. What are our steps to solving and simplifying? What's the first thing we want to do, Dominique? Okay, multiply or divide to make what? What do we want to multiply or divide? To make what type of ratios? Equivalent. Okay, so your homework is that skills practice handout on the back. You're doing 1 through 8. Today is the 15th. You're welcome. You ready to finish your quiz? Yeah.
Yeah, you can multiply the first one to get the second one, or you can divide the second one to get the first one. Whichever one is easier. And if it doesn't work, then you gotta know.
I was hiding in the middle of all my other ones.
Okay. Remember, what do we always have to do in that?